Have you ever wondered how your eyes, ears, nose, tongue, and skin help you discover the world every single day? Welcome to Simply Wonder.
Simply Wonder.
Imagine the inside of your head. It is pitch black. Your brain is locked inside a heavy skull, completely sealed off from the outside world. Yet, even trapped in that dark space, your brain knows the exact second a hot pizza comes out of the oven, or if a fast car is zooming down the street toward you. To figure out what's happening outside, your brain relies on a team of specialized field agents: sight, hearing, smell, taste, and touch. Today, we will turn wherever you are sitting right now into an at-home science lab. We're going to put each of these agents to the test with some simple physical experiments. By the end, you'll see how your body converts the physical world into a precise electrical language that your isolated brain can finally decode. Let's start with your eyes. Look around the room you're in right now and pick a single distant object across the room to stare at. Keep looking at that object, but hold a pencil up at arm's length. Now, close one eye and slowly bring the pencil closer and closer to your open eye until the pencil gets blurry. To understand why it blurred out, we need to look at this diagram showing the inside of the human eye. The eye works like a digital camera. Light enters the front and passes through a clear, flexible part called the lens, which bends to focus those incoming light rays. That lens needs to focus the light perfectly onto a curved wall at the very back of the eye called the retina. The retina is like the camera's image sensor. It catches the light so your brain can process the picture. When you bring that pencil super close to your face, your lens has to stretch and bulge to keep the light focused. Eventually, the physical lens hits its stretching limit. It literally cannot bend any further. The light misses the retina, and the image becomes blurry. Seen is the mechanical capture of light rays being perfectly aimed at a biological sensor inside your head. Now, let's test your hearing. Stop what you are doing, hold perfectly still, and listen to the background noise of the room. Next, gently place 2 fingers on the front of your throat and hum a quick song. You can feel a distinct buzzing motion under your skin. That buzzing is actually what hearing feels like. Sound is physical movement. When you hum or clap or drop a book, it creates invisible vibrations in the air around you, exactly like the vibrations you just felt in your throat. Take a look at this diagram of the inside of the ear. Those air vibrations travel down a tunnel inside your head and crash into a tightly stretched piece of skin called the eardrum. The airwaves literally beat against it like a physical drum. That shaking eardrum rattles a tiny chain of 3 bones. Those bones push against a small fluid-filled spiral chamber. As the fluid moves around inside that chamber, it converts the airwave into a signal that gets sent to your brain. When you hear a sound, you are feeling invisible airwaves beating against a specialized drum hidden deep inside your head. For our third test, grab a piece of candy, a quick snack, or a flavored drink from the kitchen. Don't eat it just yet. Ready? Pinch your nose completely shut with your fingers. Now take a bite or a sip. Notice how it tastes a little dull or blank? Now let go of your nose, take a breath, and feel the flavor suddenly rush in. That rush happens because your tongue only does half the work. The tiny bumps on your tongue can only detect basic categories, like sweet, salty, sour, and bitter. This diagram shows us what creates the actual complex flavor. As you chew your food, invisible chemical particles lift off the snack and float up the back of your throat directly into your nasal cavity. When you let go of your nose and breathe, the airflow pulls those chemical particles up into a layer of sensors called olfactory receptors. Those receptors lock onto the chemicals and send an electrical flash with the full flavor profile straight to your brain. What we call flavor is an illusion created by the necessary teamwork between your tongue and your nose, decoding chemical particles together. Now, reach out and touch a perfectly smooth surface near you, like a table or a window. Then touch a rough piece of fabric, like your shirt or a carpet. Your brain immediately knows the difference because of your skin. It is the largest organ in your body, wrapping your whole framework like a massive interactive security blanket. Let's look closely at a cross-section of the skin. Beneath the surface, there is a thick middle layer called the dermis. It is packed with millions of tiny, specialized alarm wires called nerve endings. When a rough object presses down on your skin, it triggers a specific cluster of those nerve endings. Different nerves react to different types of pressure, instantly mapping out exactly what is rough, smooth, hot, or painful. The sense of touch is a continuous security protocol, allowing your brain to map physical reality and avoid bodily harm. Try this right now. Notice the light hitting your eyes from the screen. Listen to the sound of my voice. Feel the physical pressure of the chair beneath you. You are registering all of this at the exact same time. Remember that pitch black silent vault we talked about earlier? Your completely isolated brain is seamlessly managing this massive, non-stop flood of incoming sensory data in real time. Without this precise translation system, we could not enjoy a good meal, navigate danger, or communicate with the people around us. Take the pencil focus test or the nose plug taste test and try it on a friend or family member today. See if you can surprise them with how their own body works. Once you understand the biology behind our five senses, you realize that every everyday moment, from eating lunch to looking out a window, is a marvel of scientific engineering.
Simply wonder.